Technology has been helping athletes reach their peak potential for decades, and that relationship has been supercharged with the appearance of AI. From predictive analytics, forecasting injuries, to real-time performance optimization, artificial intelligence is reshaping sports. But can it level the playing field for all competitors? I'm Divya Gopalan, and this is Connected on TaiwanPlus. To understand the impact of AI in sports and its potential as a game changer, we welcome Anthony Cioppa, an assistant professor in computer vision and data analysis at the University of Liège, Belgium. He's also the founder of the Vision and Information Understanding Laboratory, or VIULab. Thank you very much for being on the program.
Thank you so much for having me.
I'm going to start with what you are currently building. You're building systems that can essentially watch and understand a sports match the way a human expert does. Can you tell us what it is that you're trying to build and what it is that you're trying to fix in what we have currently?
So what we're trying to do is to have an AI, so a computer that is able to see the game the way a human does, and even maybe better at some point. So the idea is to extract tons of statistics of semantic information, so basically information that makes sense for different type of analysis. And we've been building this data set that is called SoccerNet that is publicly available for the research community to work on new methods that are able to analyze sports videos.
All right, so you are the founder of Vision and Information Understanding Laboratory. Can you tell us more about that entity and basically what the goal of that is?
So the objective of our laboratory is to develop new AI algorithm and computer vision algorithms that are able to analyze video, which has always been our main topic of research. And we're doing in several application domains. So sports is one of them, but we also have others, other research topics in autonomous driving, video surveillance, Earth observation, for instance.
You have an engineering and computer science background. Why did you decide you want to focus your current research on sports?
So this all started during my master's thesis when I went on an internship at EVS Broadcast Equipment, which is one of the world leader in live broadcasting solutions, and they are building solutions for sports. And at the time, it was around 2016, we wanted to explore new methods leveraging AI that would be able to watch a soccer game and extract some very basic statistics at the time. It was simply whether the team was about to enter an attack phase or was in a defense phase. And then from there, we started building up different semantics around and video analysis in AI. Yeah.
How much would you say AI is being used in sports right now, the way that you envision it should be used, or the way that your mission is working towards?
So we are a university. So what we are building is research project and proof of concept, basically, that then companies can build upon and try to come up with products. Now we see a lot of companies starting to emerge and startups in AI and computer vision for sports, whether it is for statistics, for live broadcast productions, or simply to analyze the game in a better way for the fan, for the coach, or for the player.
How much would you say professional athletes are looking into this right now or using AI generally, if not your research?
Yes, so actually a lot of companies are very interested in what we develop in SoccerNet, and we can see that through the organization of our challenges, where each year we are proposing new tasks that people can work on. So for instance, player tracking, trying to improve the following of player over time. And we see that about half of the participants are actually companies who are interested in those and that are then bringing probably that to the market. So.
All right, so you've written about adaptive human segmentation in sports videos. Can you explain what that is and how that can help with real-time player tracking?
That was a super nice paper from 2019. Very proud of that paper. And it was basically to try to have models that adapt over time in videos. Because when you train a model, an AI model, it's usually bounded to the conditions where you trained it on. So for instance, if in all of your training samples, the the weather was sunny, let's say, and players are playing under a bright sun, but then suddenly it starts snowing. And then your model might not be able to adapt to this new condition. And so what we wanted to bring basically is to have lightweight models, so models that are able to run in real time, to be able to run under any specific condition. And so for that, we developed Artus, which is a method based on a student-teacher approach, where basically you have a student, so the lightweight model, that adapts over time by leveraging some very slow but also very performant AI model.
So help me understand what you're training your AI on. How do you train your AI? And how are you getting the data to create this model?
That's an excellent question, and it's something that we've been working on since 2016, actually. So when you want to train an AI model, you need data. So that is the raw video. So for instance, let's say you have 500 games of soccer videos, but then you also need to show the AI what it needs to achieve. So for instance, if you want it to detect players, you need to have a human that manually annotated bounding boxes around those players. And this is taking a lot of time. And so with SoccerNet, what we wanted to do was to bring out this type of large-scale data to be able to train AI models for the research community in open access.
So basically, ultimately, what would happen is you will have a game or a set of games by a team, and then it will be studied, that data set will be studied, and then there will be recommendations given. Can you just explain what the process is?
Sure. So to be able to train an AI, like I said, you need data that is annotated, basically. And before 2016,
so
in computer vision in sports...
explain to me what kind of data that is annotated. So particularly in sports, or what is the data you're looking for?
So, for instance, if you want to detect all the events that are occurring during the game, you need to have a human that went over all the videos on your data set, that watched those videos, and that annotated every moment where something happened. So at this exact frame, there was a goal. At this exact frame, there was a kickoff, then a foul, and so on. This can be then used to train the AI model to replicate basically what the human annotated, but in an automated way, which in turn then is able to predict on other games where humans did not annotate. And this is the whole point, is to automate somehow the process of any task, whether it is event detection, player tracking, player identification, and so on.
All right, so on that note, tell us about your ongoing collaborations with FIFA. What kind of work are you doing with them, and what are you hoping to, what is the end goal of this collaboration?
So we worked together and published actually a paper in 2023 where we looked into header spotting. So spotting all the heads of the player on the ball. And this is to be able to automate the process of finding those headers, which can then be used by a medical team to assess player concussions and so on. And so what we did together, and that we are working on as well, is to try to automate that process as much as possible and to be able basically to retrieve all of those header moments, not by a human watching tons and tons of videos, which would take months or years to do, but basically trying to come up with algorithms that are able to do that precisely and as fast as possible.
So help me understand then, what is it, when you're looking for, exactly what is it that you're looking for when in relation to concussions or to injuries?
So we are doing the computer vision part, that is extracting those data from video to clips, let's say, that are centered around each header. And then we transfer that to the medical team for further analysis. Yeah.
Right. Okay. Your computer vision tools currently focus on football, but can it be applied to other sports in the future or even currently right now?
Yeah, this is what we're aiming for, actually, is that everything that we have built on soccer could be potentially used for other sports. So we have basketball that is very much likely, and you have team sports like ice hockey, hockey, field hockey, and so on, that are also sports that are very similar in some sense. You have two teams competing against each other. And so the models should be transferable, basically. All we need to do to be able to transfer from football to other sports kind of team sports is to have the data for it. So for SoccerNet, we trained all the models on soccer, but if we want to apply them to basketball, we just need to reannotate some kind of data on basketball. Now we are also working on other type of sports, and especially on individual sports, and starting new work on that field as well, where the dynamics is a bit different as well. You only have, for instance, two opponents in tennis or in boxing, and that's also a super interesting line of research.
So you mentioned minimizing injuries, particularly what you were doing with FIFA, but what other aspects of the game are you looking to, or can this enhance?
So recently we started a new research grant with the UEFA, so the European Football Association. And this was to estimate player fatigue, for instance. And here we are working with broadcast data, so everything that is just available from videos, to try to estimate the fatigue of player, because so far it's actually very difficult to do so. Either you have to ask the player during the breaks or after the game, they have to run some lab tests, and this is taking a lot of it's very intrusive somehow. And so what we're trying to build now with UEFA is to have this automatic analysis of the state of fatigue of the player just from the broadcast, which could be super helpful to try to prevent injuries as well.
Now, you've also talked about using generative AI to create new camera angles or even views that wasn't in the original footage. How do you hope that this will enhance or improve how we view and analyze sports?
Well, our starting point was that wouldn't it be great if we could see the goal done by a player from the perspective of the player, basically. But this cannot be done with usual broadcast cameras, right? You don't wear, like, players don't wear a body cam. Referees are starting to do so, but not players themselves. And it would be great to have this kind of point of view. But unfortunately, this is not available. And so what we are working on, and we have published several works on the topic, is to try to reconstruct some kind of 3D scene, photorealistic 3D scenes from these available broadcast cameras. So you have all the cameras that are around the stadium, basically, and you're trying to build up any point of view within the stadium, which could bring, for the fan, some kind of new perspective on the game as well.
Very interesting. Now, before we continue, we're going to look at another kind of sport in which artificial intelligence is being used. AI is also reshaping training and strategies in mind sports. Former world chess champion Magnus Carlsen told TaiwanPlus how he had to use AI-powered chess engines to enhance his training and prepare for high-level tournaments.
I think there was a revolution when it comes to AI in chess, late 2018, but mostly early 2019. I think there was a big difference back then, which players had teams and that had the capabilities of using the sort of early versions of neural networks. I think ever since then, it's become kind of more normalized that everybody uses kind of the same neural nets and hybrids and also traditional engines.
In what ways have AI-driven analysis tools impacted your approach to studying and understanding complex chess positions?
I think much like many other good chess players, my understanding of certain positions, certain strategies has evolved a lot over the last 5-6 years, and I think it has helped us understood how we see different factors, specifically as it ascertains to more sort of long-term factors such as king safety, and probably made us a little bit more susceptible to giving up material not for short-term advantages, as is easier for humans, but more for long-term advantages.
How has AI influenced your playing style, especially in terms of adopting unconventional or computer-inspired moves in competitive chess?
I think AI certainly has influenced both me and others in the way that we we play. I think a lot of people have broadened their horizons. We understand certain positions differently, but at the end of the day, I think for most people, there's the balance to be found, because we know that when we judge a position that's over the board, we judge it more based on what a human would do rather than AI.
What are your views on the role of AI in modern chess? And how have you adapted to the increased reliance on AI tools among your opponents?
I think that AI tools have been a good thing for chess, but it's also been a great equalizer. It's made it much easier for players to gain knowledge faster, and so there's much less of a knowledge gap, especially when it comes to openings now than it used to be. So it's become kind of easier to survive openings, but harder to create games. But overall it's certainly enhanced our understanding of the game a lot. So I believe it's a good thing.
That was five-time former world chess champion Magnus Carlsen speaking to our reporter Shivam Pal. So Magnus Carlsen talks about how it's helped with his strategy and training, and how it's a great equalizer. So I want to break down some of the points he's made there. How currently is what the work of VIULab, so the research that you're working towards, how much of that will go towards strategy for football teams or sports teams?
So the objective is that then the data that we extract from videos can be used by coaches and by players to improve their performance. So when we're talking about team sports, of course, team formation and understanding the opponent is super important. And for that, if we can extract, for instance, for any opposing team, the strategies that they put in place, this is something that we are currently investigating, whether we can, from positional data, also try to come up with team formations that are usually played by certain teams, and that can inform the coach, for instance, for his next play. Now, for individual sports, it's a bit different, because then you are not only interested in your opponent, but especially in yourself.
Yeah, absolutely.
Yeah, you're super interested in your own movement. And so for that, we can use what we call also event-based cameras, which are super fast cameras that can analyze the motion very precisely, and where you can extract useful information on how to improve your moves.
Now, you talk about using base cameras and analyzing the motion. Now, where is it possible, or how much currently is it being done with your work with FIFA, where cameras are being placed at games for you to analyze, or for your lab to start analyzing the different viewpoints?
So our objective is to use what is available usually. So that means that we are using only the available broadcast cameras to do the semantic analysis with AI. Now, what we want to bring out to the field is, especially for individual sports, is to bring these extra cameras as well. But this is ongoing work. Yeah.
Right. And so at one point you can envision for a player, or perhaps even for certain games, where specific cameras are put in specific positions for AI to future analyze and understand the data.
Yeah, the only thing is that you don't have to distract the players. Like, the center should still be the game, and everything that you add on should be as non-intrusive as possible. And this is why we feel like computer vision is a great way to achieve this, because basically you're not putting sensors on player anymore to analyze different parts, and you're capturing all of this at a distance.
What is the danger where it's individual teams or certain commercial teams get access to this kind of technology and others get left out? Magnus Carlsen speaks about the great equalizer that AI is in chess. Is it the great equalizer in all sports, or let's just say football for now?
I feel like too. Basically, everything that has been developed the past years, so the different type of technologies that are used, are basically only available to the top leagues and clubs. So when you see a World Cup game, for instance, you can see like the semi-automated offside detection that is used nowadays, but you don't see that for younger players. And what we want to bring with this computer vision approach is to be able to analyze the game in the same way for professionals than we can do for amateurs or young people, because everyone would get the same kind of change during the game and be able to experience the same technologies and how they can help their own performance, their own strategy, and overall the better experience for the fan as well.
So Anthony, along with your collaboration with FIFA, you are doing some other joint projects, and there's one that you're doing with Saudi Arabia, I believe, called SoccerNet. Can you tell us more about that?
Yeah, sure. So this is a collaboration that has been lasting since 2018, where we have been building the largest collection of data, methods, and benchmark for soccer video analysis. And so the idea is to provide to researchers a huge collection of data to train their AI model on nowadays more than 20 different tasks. So when we're talking about tasks, we're talking about player tracking, event detection, camera calibration, and so on. And so the idea here is to be able to provide researchers with an open benchmark where they can compare methods against each other. And this is because when I started my PhD back in 2017, there was actually no large-scale data set that was available, and everyone was doing their own research on their side, on their own private small data set, which meant that there were some issues, basically. So when you are trying to come up with a new method, how do you compare it with what was done before? Because you don't have access to the data, you don't have access to the evaluation protocol. And so it was actually very hard. And this was the situation back before 2018 in our field. And we wanted to bring that together with more data and publicly available so that researchers can actually do research and benchmark and improve methods on different tasks. And this has allowed us to drive the research basically in computer vision in football a lot, because nowadays SoccerNet contains about 850 hours of videos. So for our viewers who might not have an idea of how big that is, that represents almost one full month of watching videos day and night, actually. And that is annotated with more than 20 million manual annotations on different stuff. So all the events, all the positions of the players, and so on. And this has become a fantastic resource for the research community to work on and expand. And in order to drive that
Please go on.
And in order to drive that research even further, what we have been developing is those SoccerNet challenges. So these are yearly challenges that have been running since 2021, where we propose some tasks that we feel like are interesting for a research community. And then we are basically releasing new data and new baseline models where people can start picking up from that and try to improve the result and try to reach the top of the leaderboard at the end of the year. And basically the researcher that arrives at the top then gets rewarded with recognition, of course, from the scientific research community, but also some prize from some of our sponsors.
So competition within the competition. Where is that data coming from? Are you focusing on a particular region or a particular tournament, or where is all this data coming from, and how relevant will it be for those outside the region you're looking at?
So far, SoccerNet contains mostly videos from Europe, so from the European competitions. So we're talking about La Liga, the Premier League, the Champions League, and also some Swiss League games. And we are looking to expand also, like I was saying, to more amateur sports, and which is in our let's say, plan to release over the next years. We are also using synthetic data, which is more easy to work on as well in some sense, because when you have these simulators, so you can imagine them as video games, basically, you have access to all the control points. So you can control the weather, you can control the position of the players, you can control the plays that they are doing. And basically you can try to come up with scenarios that are not available in real soccer. And you can cover much more dynamics of the games as well. And so we are starting to build also some challenges around those synthetic data as well.
What would you say is the toughest part or your biggest challenge right now with VIULabs in trying to build this model?
Yeah. So I would say that nowadays, all of the low-level kind of semantics, so everything that is within the image directly visible is almost solved. So when we are talking about detecting the players, the tracking is also getting somewhere where the performance is starting to get really good in controlled environments as well. What we are moving towards nowadays is more general questions, like if you want to ask an AI, okay, who was the MVP of the game, for instance, and then he has to analyze over a long period of time every player that has played, how they have played, if they made good moves or bad moves, and so on. And so these kind of more high-level questions are actually super relevant today and are also very hard for AI models at the moment.
Interesting. How's your research currently funded? Would the results of what VIULabs do be eventually available for everyone, or is it more a project that will eventually be sold commercially?
So everything we are doing is open source at VIULab. So all the data, all the methods that we develop are publicly released for research purposes. So this means that anyone can pick up those models and try to have fun at home if they want. Everything is available. We have our website, our GitHub repository. So for those of you who know coding, well, you can pick up everything that we have developed and basically try to play around.
So finally, do you think will future developments in AI enhance or diminish differences between athletes? In essence, what you said about evening the playing field.
So my hope is that everyone gets the same chance, basically. So when you have scouters, for instance, at the moment they are going to games of young people in famous teams, but they are not able to go everywhere in the world, right? And so not every kid, even if he's talented, more talented than others, gets the same chance in being recognized as a talented player and then gets transferred to a big team. And so my hope in the future is that those AI models are available basically everywhere for everyone, such that everyone gets the same chance to success, basically.
Well, thank you so much, Anthony Cioppa, for joining us from Liège in Belgium. This has been a great conversation and certainly an education and a very steep learning curve for me. So thank you so much for explaining it so well.
Thank you so much for having me on the show.